All right, I think we're going to get going here. If everybody's ready to go. I'm looking forward to a really interactive session here. So I do have a few slides, like informative, but beyond that, we're going to dig into models. I'm going to take you into the world of food insecurity and some of the challenges that we have with data, looking at two aspects. From the supply chain side, yes, we're a company that's I got a colleague over here from the company I used to be at, a wholesale distribution electrical company. And guess what? A lot of the same analogs in food insecurity. It's trucks, it's picking things up, it's delivering, it's warehousing, it's efficient process. That's all great from one side, but we've got the human impact side too. How are we actually having an impact in the community? And the question for us today is food insecurity. How do we combat food insecurity? How do we meet the needs, the demands of certain communities? So not looking at, so it's a tri-county area, Macomb County, Oakland County, Wayne County, okay? There's one aspect of it is to look at it at a macro level, but then at a micro level, we have data that goes right into neighborhoods based on the census. So we know where there are more compromised or areas of need than maybe even the zip code or the census tract, the neighborhood right next door. So with that as a landscape, that's what we're going to do today. Someone advanced me. That was really good. Wow, that was automatic. So did everybody see those two slides? I'm obligated to show you the first two slides, is what I've been told. So a little bit about me. I have been in for probably over 4 decades in data analytics, development, architecture, IT broadly speaking. I'm a hands-on CIO. I can get into the network data center. I can rack and stack, and I love being involved in business analytics and building things. I have a colleague with me today, Amy Shaker, who's going to come up in a little while and actually run one of the models for me, because I learned here I've got a pointer, a mic, and a laptop. It's not going to work. So we're going to do that. So what else? Let's just jump right into it. So a little bit about our supply chain and what we're dealing with in terms of fighting food insecurity in the Tri-County area. So there are a little over 4 million people in the 3 counties. There's about 600,000 of them in food insecurity. So for those of you who are informed about that community or that social issue, great. But for those of you who are not, let's break it down. So 600,000 people. These are people that may be a working family. They're working 9 to 5, but what they're bringing home does not fulfill the total home budget. So what we've learned in food insecurity is, think about it for a second. What are the priorities in a family budget? If you're on a fixed budget and you don't have enough coming in to cover, got to pay the rent or you're going to get kicked out. Got to pay the utilities or they get turned off. And we go down the line. Guess what's one of the last priorities? Discretionary spending on food. We find that sometimes adults head of household is the one not eating nutritionally because they're feeding the kids, kind of thing. So it's a complex problem. It's not just families, it's seniors. These are senior citizens who've been left behind. They are in an apartment. They can't get out. They're stuck. We've got vets in the same condition. There's a story a couple years ago. I was at the front desk and the call came in, and this vet says, I've been in the room for 3 days. I haven't eaten. I'm an independent, but I got a condition right now in the moment where I can't get out of my place. Please help me. So it's a very wide spectrum, all walks of life. People come from different places, and our business model is we serve people. If you're in need, we serve you, kind of thing. So now we got this supply, back to the supply chain. We're moving 50 million pounds of food, and you can look at some of the stats here. About 750 truck pickups and drops every single week. So we're talking 35,000, in terms of logistics for the whole year. That's a lot. Okay, let's see what else we got. 35 drivers. We have 60 volunteer drivers that their extra job or After they're done with their regular work life, they come to us and they volunteer every week. And there's 60 of them that are picking up and moving food all throughout the community. And DoorDash and Amazon has donated drivers to us. So those senior citizens and those vets that are homebound, they cannot access food. We take it to them through Amazon DoorDash. 35,000 volunteers every year. So, thinking about data and analytics, that's 35,000 prospects of people that are helping us and might want to engage further. So the more you think about kind of our business model, the more complex it gets and the more opportunities for data. So this is how we use analytics, all of these things. We're early adopters in some of the areas, and that's a challenge for, I'm sure, you folks in your businesses. It's a challenge for us too, but we're making headway. We've got big plans for growing and meeting more people's needs in food insecurity. The supply chain, we got to optimize it, so we're stewarding our resources the best, and all the way down to using it to find grants and fundraising. And we're starting to use it for forecasting as well, so that's pretty exciting. So a couple unique things about our business. It's an orderless supply chain. Those of you in manufacturing or retail or true wholesale distribution, there's a manufacturer order, there's a purchase order. It comes in and you check the boxes, make sure the goods are coming in. On the other side, you got a customer ordering something, okay? And you're checking to make sure you're pick packing and shipping it and it matches. That's not what we're doing. We're rescuing fresh food up to, let's say, 50 million pounds a year from 400 different grocery store sources and also distributors in the food community. So a company like Mastronardi, they have like 6 products in various retail stores. They mass produce through gardens, indoor gardens, fruits and vegetables, okay? They have a surplus, so we rescue that surplus in massive quantities. Like we're talking 200,000 pounds and upwards a month, 300,000 pounds. So you've got all this food coming in, and it's orderless, meaning on any given day we don't know what's coming in, really, and every day we have some control over what we ship out, but in some cases we're picking it up from the store and taking it right to about 200 agencies that distribute the food in the neighborhoods. So it's a little bit different model from a data point of view. There's no order. So it's more about flow, expected volume coming in based on history, and trying to make sure you don't stockpile food in the warehouse that's going to waste out. So it's a fluid engine. I already talked about sometimes we're having to get food to table from the day we get it to a couple days later. It's on someone's table kind of concept. How do you do that when you're moving 50 million pounds of food that has no orders? Let's see what else. Another difficult thing, tight windows. These aren't, our distribution of food is not stores at 7 o'clock to 10 o'clock at night. It's mobile pantries from 10 to 12, only on the second Tuesday of you get it? We do have some 24/7 rescue centers, but they're very small in scope, okay? Soup kitchens. So you're trying to get the food out in this model to 250 locations every week, and you don't know what your volume is going to always know exactly what the volume is coming in. And then another thing about our model, it's not a financial model in the sense of we're making a profit. Of course we're nonprofit, but all the food is given to us pretty much for free by all these providers. And guess what? We give it away free. So now you're talking about running the business. Well, we're not running it on profit. What are we running it on? Just let's hold that question. Just hold that thought. All right, so design goals. So several years ago, Amy and I, and it started, Amy wasn't even in my area yet. She was in another part of the supply chain. She was busy learning the whole supply chain, which became a huge asset when we started building up data intelligence. It was invaluable. But we were pondering these things on a whiteboard. And we said, well, of course we want it real time as best as possible. But also, not only real time, but we have measures and indices that are provided by, let's say, the government or other sources I wanted those things to flow and be updated immediately. So all pipelines, think of it, that they're ready to be ingested, whether it's daily ERP data, it's once-a-month data, it's once-a-year data, whatever. We're not going to rebuild the model every year. Okay, obviously trending, predictive analytics is really important. And we have many, many data sources. So it's a simple food organization with 120 people, but our sources of data are all over the place. And our goal is to bring them all in and not analyze them in isolated silos of data, but literally imagine bringing all of the data sources together in a visualization where you're seeing the whole ecosystem running. That was our goal. And today I think we're going to demonstrate that we're getting very close to that goal. Really weird time measures. So with the tight windows, time, geo, the 3 counties down to the neighborhood. So you've got customers all over the place. They're traveling all over the place to get the food. And then we got nutrition and the index of what areas are more food insecure than others. So a lot of measurements and variables that we're playing with here. We wanted flexible models rather than just a KBI board like a dashboard. First thing I'm going to show you, one of the first things is a dashboard, but we're going to start clicking through and you're going to see they're interactive models that people can actually use and manipulate to solve problems. Agnostic, this is a unique one. My goal was to create a BI architecture that was agnostic to any ERP system, any one of those sources. Mike, what are you talking about? The first thing you do is you take the source system, you map the pipeline, and you build a star model, and away you go. But what if we challenged our data architects? Don't exactly do that. When you're bringing the data in, don't just map it in field for field. Think about a model for the business that will last. It will survive any ERP system. So in 2 years that they flip the system, all we're doing is remapping to the star model, to this more harmonized model that represents the business, not the ERP system. It's a little bit different way of thinking about things. All right, so where do we start? Anybody who's getting started in BI, I would highly recommend, in my data architects and scientists, I've been doing it since 1981. In fact, just a little history lesson. When I had to pass my class, my senior level class, undergrad, in data management, my SQL exam was on paper because the big servers, the architecture wasn't perfected yet. So I had to write SQL code on paper, and that's what I was judged on. So I've been doing it a long time. I've learned normalization theory, all that good stuff. You want to get started? Easiest thing to do. Write what I call a super query, and Larry knows what I'm talking about. The previous job that I did, we leveraged this big time. Write a query, a super query, that denormalizes the data. Does all the joins in the query. So what you end up with is a flat record that when you bring it into a BI space, you can do whatever you want. You can get running fast, and you don't have to wait a year for the data architects and IT to figure out the data model. If you can query it out, get it out, flatten it out, and you're off and running. In fact, that's what we did. First, Amy spent a lot of time building out these beautiful Excel models. Okay, we got time slicers in Excel, we've got pivots, we've got variables that were goals that we're shooting for. And it was wonderful. In fact, Amy and her knowledge of the supply chain and this model, which had about 12, maybe 15 tabs of visualizations, she could answer any question in the whole company, anything anyone ever asked. What's the problem with that? We published this to everybody. Did everybody use it? What do you think? Why not? Why didn't everybody use it? It's got everything. Amy can answer all the questions. What? Yeah. Not every user is a data person. And what we started to learn is people didn't even want to click to the tab, and we already had it baked and ready for them to go. We gave them the previous month's distributions to all agencies. You know what they said? Mike, can you have that emailed?
I was about to say
right?
Yeah, I want somebody box this PDF.
Right? Exactly. We just want to see the results. go back to the original thinking. We didn't want static. We wanted flexible, interactive models, but not everybody's there. So what we found is there's a few people, smart data people, that took off with this, and they used this to create their KPIs that were published in PDF, for the organization. Very static, linear, same old, what we're used to. So that's where we started, but it was really cool. We had the time slicers, and people could go back in time. That was neat. So here's another early rendition. This is a cool model that Amy put together. I said, let's have a geo model that takes our agencies, and relatively the circle that you're going to see animated in a second, the bigger the circle is, what do you think that represents for an agency that gives out food? The bigger the circle, exactly. So, and back to the time windows, we have 250, let's say, around Detroit. It's a little less than that. We're covered. Everybody's covered. You think so until you watch the model. So this time slicer model is set for a couple hours here, and let's see what it does. In the back, it's going to be a little hard to see. We early in the morning, we're going to get to about 10 o'clock, and this is all agencies, and they light up like a lighted tree, and you're seeing them all over the place. And what happens when you get to nighttime? They disappear. So we learned in using that technique that we didn't have the coverage we thought we did. And now what it's going to do is going to look at just 1 week and a Tuesday. Not a lot of lights on the tree. What does that tell us? We think we've got good coverage, but it really means that you need to be that close to those agencies only on the first week on a Tuesday kind of thing. Now, if we do other days, there's other things light up. But that creates a challenge, doesn't it? Not for us getting the food out, but for who? Accessibility, okay? So hold that thought, accessibility and time. And let's keep moving. So it took us a couple years, but we sought all kinds of consultants, and we thought about hiring someone like a data scientist that could come in and help us build this architecture. Guess what? We failed miserably time after time with trying to do it. We hired a programmer. It inched us along the way. I found it challenging to find a data partner who could take the complexity of what I'm talking about and put it all together. We did find that in WIT, and guess what? It was this conference a year ago that I even found out who WIT was. 3 months later, we engaged them. And in 3 weeks, we had our first visualizations. I'm not setting the bar too high for all customers, WIT. It did go very well for us because the talent was there to understand our business and understand our data and to visualize it and not just do the standard business, just some metrics with some meters and things like that. So basically, it's Azure Data Architecture and whatever they're calling it today. If it's Fabric today, it's Fabric. If it's something else tomorrow, it's that. But it's basically Microsoft. SQL pools, yeah, we could debate that. I've used SQL, well, I told you, since 1981. But that's not why we picked it. It's just, it's there, it's usable, we're nonprofit, we get a great discount on Microsoft services and that kind of thing, so it just worked. We publish a star model to Microsoft Power BI. We use for the geo mapping, we've played around with Azure a bit. We're kind of leaning on Esri mapping, which seems to allow multiple dimensions to be brought into the model, which is what we're after. I don't want to just see where are the agencies. I want to see what's their capacity, when are they open. I want to see food insecurity indexes layered on it. I want to see in the future DTE power grid power outages in the city of Detroit. What's the impact? I need a geo model that's going to take multiple layers. All right, so we came up with multiple visualizations. I'm going to show you some things. We're actually going to go 2, 1, 3. Map the meal gap is indexed food insecurity data that is provided by Feeding America. It's based on the census. Then they take economic data, like cost of food in each neighborhood. They do this for every census tract in the whole United States. So we're talking groupings of 4,000 people or less in a neighborhood everywhere in America, economic data and food insecurity data. We're going to look at that one first. Then we're going to look at supply chain. And then we're going to have some fun looking live. And my Wi-Fi, my personal hotspot, was working until the Marriott Bonvoy app said, no, you're using our Wi-Fi, and it killed the whole thing. But I think I deleted the app, so I think we're going to be okay. All right, here we go. First model, map the meal gap. So we're talking about multiple types of data. I was thinking of visualizations that wasn't just one variable or two. How about three? How about four at the same time? This starts to get to that. So in the upper region, we have a completely sortable Excel type of rows and columns of data. But we can drill in. If we touch on anything, it will have an effect on the rest of the map. So the geo map, those are all, that's the whole Tri-County area. You can see on the left, they're all lit up. And the darker the color, the more the food insecurity. So I was told I can't walk over that blue line, so I'm going to use this. So, of course, in metropolitan inner city Detroit, but we also have, you see some darkness over towards, the Willow Run district, that kind of thing. But look up here. What do you think this is? Mm-hmm. And what do you think this is, this white space? Thank you. That's no fair. You know the data, Alfredo. Okay, so we're going to run the model now. Hopefully this will work, and I'll try to talk while it's happening. Is it running? Okay, it's not running. Yes, it is. Okay, so up at the top we have county, we have zip, we have different levels of food insecurity. I'll let it catch up with me. So total population, there's that 4 million I talked about. Okay, food insecure, 600,000. 1 in 7 people has food insecurity in our area. 1 in 7. We've got some demographic information we can break it down to. We've got economic information, and we got disability. We're going to look at disability in a little bit because I think we talked about it before. Well, we talked seniors and vets, but what about a neighborhood that's intense with disability percentage? Again, accessibility to food is a problem. All right. I think our model stopped. Oh, it's still going. No, it's going again. So give me just a second. No. Ooh, it's slow. Or it might, you know what? While I was talking, it was probably going. Okay, so now we're going to come down in this other quadrant. You notice that it's all 3 counties, and now we're going to play. So we're going to click on Oakland County. The map re-renders. All right, so we're looking at there. We could go up here and expand it out and investigate those geos and see what's going on. In fact, it looks like my automated demo is doing that. So we're going to zoom in. And we're going to see, with more specificity, with bigger eyes, what are we talking about in Oakland County. All right, and then we're going to come back. Going to make it all big again. And then we're going to zoom into Wayne County. And then we're going to ask ourselves the question, where is most of the food insecurity? Well, there it is, 30%, so 1 in 3 people nearly, in that particular zip code, okay? Now let's find out where the most food insecure people are. So we're going to touch that. Ironically, that's 48228. I grew up in 48228 in Detroit. So I'm very familiar with this geo. We're going to touch on the geo. It renders the map. Do you see the idea here? We're letting people investigate and play and figure out food insecurity on multiple dimensions. All right. Let's go to the next one, supply chain. So basically this first page is more static in nature. We've got donations, which is inbound food. In the orange over there in the middle, we've got the turns of inventory that we do bring back to the warehouse that are perishable. And on the bottom, we've got distribution. We've got up here on the right, we've got this thermometer that is basically our stretch goal for the year and where are we at any given time. And then we start to break down. This is at a really high level what our business looks like from a supply chain point. But we started to roll in for the staff things like Number of household servings on the bottom, 73,000. So what they're doing in the supply chain results in 73 people being fed, 73,000 households in the month of March. Okay, I got a quick animation here for you. So what we can do is re-render the model and go back in time. This is a really cool feature. So we're rolling back. We're comparing March to what happened in October. October is, what do you think's happening in the fall in terms of agriculture? Yes, exactly. There's a bounty. So for those numbers to go up and meet goal or surpass goal doesn't surprise us. So now let's go to, now we're going to go here. So this is now digging into the inbound donations. We use a volumetric. That's food in terms of visual. So numbers are great, but being able to see that that's what we brought in terms of the different classes of food. And let's let the animation run on this one and watch what this one does. Got to follow the bouncing cursor. 3.76 million pounds coming in comparative to February. And then those are the categories of food. And we can hover over these and get some details behind that. All right. And then we can actually see who the top, I talked about Mastronardi, the hydroponic people. They brought in 200,000 pounds, and that was up from the previous month where they did 100,000. So we're letting the people who insource the data have these tools to see how things are going. And then I clicked on Mastronardi, and I specifically can see the tomatoes and the peppers that they brought in. And notice that the map is re-rendering as we click around. And this is the different frozen, refrigerated, shelf-stable foods. It gives the users all kinds of tools to be able to look at. This is trends. So when someone thinks, oh, we're doing 4 million pounds a month, well, not exactly. We're doing this. And going into the future, we have an indication of what it may look like going forward. Okay, inventory. Kind of the same look, but some different things. So we know how much inventory we have. We can see it in terms of pallets. How full up are we? We can see the categories of foods. So we're responsible for getting people balanced nutritional food at the agencies. Well, this is going to tell us what we got. That coupled with what we, not randomly, but we get on a perpetual basis from the stores, we put it all together and we start to see, we have analytics that tell us how our food is moving and in what categories and quantities. Now, we took an approach where we didn't massage the data too much. We let the data speak for itself because that is what they're using every day. And if the visualization of data, like the 33 fresh vegetables, if people don't understand that, then we need to talk about source data and how we're using it. If that doesn't make sense to them, we need to change that. Rather than putting a lot of layers of coding on it to reinterpret what things mean. We tend to let the data speak for itself. Unless the data is horrible, in which case it needs a little help. We try to avoid that. Okay, you get the idea. Okay, this is on the agency distribution side, a new category up in the upper right hand. Now this is affecting neighbors, the people we feed. That is telling us on goal that for the total amount we would like to distribute a month, like what should the goal be? And that's what the percentages are. And in some months, because we can't predict all we're going to get, we can see that we're behind on protein in the month of March. Winter does tend to be, those winter months, harder to get the stores to give us protein. So that makes us think, using this, well, we got to do something to augment that. Let's go back to the distribution side and maybe identify one of those top donors and see if they can give us some more protein. Did I run this one yet? All right. So again, similar things. We can see the trend analysis. They can see who the heavy hitters are. They can dial in to find out where the food is going. And we can comparatively see who might be getting more of some product than the other. So it makes us accountable to how we're packing those trucks to get them out on those routes. So the whole model re-renders again if we dial in on a particular agency and the data re-represents itself. So you might be thinking, wow, all this bounty of data and these visualizations is so much better than Excel. Guess what? We still have the challenge. We have education, we have seminars. We did one where we had the board, the executive leadership team, and the staff in the same room, virtually and in the room like this. And we talked about these models. And why aren't we using them? Like, the goods are right there. And this isn't looking at rows of data and columns and having to do your own computations. It's telling a story. And that one, that's kind of a, let's see, which one is this? This is kind of a scoreboard. So we can see how well are we doing. Church by synagogue, by civil service, social service organization, or civic organization that's giving out the food. What do we need to adjust to get things into alignment? Okay, now we're going to go after the really, how am I going to say this? That's all great. Supply chain analytics to run the business, optimize efficiency and all that. It's great to look at the food insecurity index and know where there's more need than not. It's another thing to put all that data together. And so we've got need, which is the food insecurity by geo. We've got demand, which in our logistics model, we know how many pounds of food need to go out to those agencies to get the food to meet the demand in their community. We can track through ERP what really went out the door, okay? So we can measure what was demanded, what did we supply, and how does that measure up against the areas of need, and then the last measure, at the same time, what people went to what places to get that distribution. All 4 variables at the same time. Now that may sound really complex. Oh my gosh, we got to have AI do it. Well, you could, and I'm going to show that in just a minute how we are using AI to look at some what I call tribal knowledge behavior of our drivers. I'll explain that in a minute. But here's where, Amy, if you wouldn't mind coming up and helping me, we're going to do, this one's real time. This is running through my mobile hotspot. This is our Power BI model, more live. So I need to come over here so I can see it. So what we have, let me use the pointer that I've already destroyed. Actually, there's snap, it's back. Okay, so what we have is we can look at this analysis of those 4 variables by city, by zip code. Right now we're going to do by city, and you can see that I've targeted into Macomb County. And here's the variables working with each other. Total population, number of food insecure people, percentage, and then we compute based on a measure of about 60 pounds for each family for like a 4-person family per week. So we are using a multiplier to determine need from the census of people food insecure. So we come up with a pounds needed to feed that area. That's a lot of food. So I told you we put out 50 million pounds and Macomb needs 32 million, okay? So, okay, what's going on there? We need more than just Forgotten Harvest in the community to take care of people. We are supplementing, we are contributing. We're a big player. We're probably the biggest player in terms of volume over the 3 counties, but it needs other people to do it too. So in the future, I would like to figure out a way. Remember I talked about making the data model agnostic? Here's a use for it. What if the other partner is supplying food in the Detroit area? Simply give me the mapping of their ERP data to tell me what they're doing in these communities. Now what have I got? I've got the whole picture of my partners who are doing the same thing. And from all indications, it looks like they would be willing to share in that data. And what am I going to do? Probably give away the data model so it benefits them as well. So our economics are a little bit different in the nonprofit space. We're not competing, we're working together. But that's why that looks, so you could almost double the gap. So here's the gap. So this is what we needed. This is what we distributed. That's the gap. Some people would look at that and go, oh, gap, that's really bad. No, we see it as gap as opportunity. how can we do more? How can we raise more money? How can we have those 35,000 volunteers a year helping us get it out more efficiently and better? What else do we got here? Amy, you want to slide it a little bit to the right on the bottom? See what all other goodies are in there. So we have a percentage of met, and here's the clients served. So these are the physical people served. Now, I will tell you, I've been playing with the filters a little bit. I'm not showing you that. There's like 25 filters. You can manipulate the model. I've got it skinnied down a bit. So I'm about 9 minutes, right, Alfredo? Perfect timing. Okay, so now we can take a look at how many people were actually served and how many unique individuals, and we are computing unique individuals. And that's a tricky thing to do when you think of time and you think of all the people and how to count them as unique and looking at things from a uniqueness standpoint as opposed to like McDonald's used to do with the 20 billion served to date. Okay, that's great, but what does that really mean in terms of how many people are eating at McDonald's on it? It's probably a really bad analogy because my food experts would argue that that's maybe not the best nutritional food. I love McDonald's, so it's high on my books. And then so what we also have down here is kind of a not subjective, but it's a qualitative measure. We've decided what the thresholds are, and we're scoring how well we're doing in cities where we're underserving or overserving. And of course, you might realize, you want to do some sorting here, Amy? Your choice. So we can manipulate the model. We're within Macomb County. We can take a look at where the gaps are bigger. We can dial in. It looks like there's a huge gap in Roseville. We could start to analyze our effectivity across the Tri-County area. Now, on this session, I said, let's play what-if games. I'm hoping, I would appreciate if you're really trying to understand how we're doing it, but I'm hoping also there's maybe techniques here that you can use in doing your own customer demographic analysis or qualitative or quantitative kind of analyses. Anything else you want to do in this one, Amy? Any suggestions? You're the master of this one, not me. Okay. Let's go to, last thing, let's take a look at the other anticipated households. So another way to look at the data. Good. Mobile phone, keep working. Thank you. So, and remember again, this is from a, this one actually is looking at anticipated households. So this is forecasting. And this is taking a look at, not from a city perspective, but it's taking a look at specific agencies. How is each one, what are we expected to serve them? And how can this data be used to inform the warehouse who's in control of loading those trucks, or maybe even in the drivers one day, and put that thought away for a second, because they're the ones who claim to have all this tribal knowledge of what's happening out there. They're visiting the stores, they're visiting the agencies, they have this sensibility. They don't have this in their head. But if we saw an anomaly in here that we weren't serving certain ones, maybe there's a way to inform. Maybe it's even using AI to use the data models to inform them. They have handhelds. They go around all day. We've automated it like Federal Express. What if when they get to the stop, it's using this to inform them about what they might do if they've got control of that inventory on the truck and serving the ones? Well, we got just enough. It looks like Marriott Bonvoy got a hold of my thing there. So thank you very much, Amy. We're going to just do a couple more things here. So this is an AI model. So have I got about 5 minutes, Alfredo Maca? All right, perfect. So we use a system called FarEye, and they some of their customers are HelloFresh, companies like that, doing the same thing but for profit. They're a global organization. They're based in India. They have like 220 developers, and now they're getting into AI. So I posed a problem to them. We used AI to optimize the routes for the drivers. The drivers have the tribal knowledge and feel that they know what's going on. What do you think happened the first time we went full optimization over here for the drivers on their handhelds? They've been doing the same routes. They're specified routes. They love their customers. They love their store pickups. And we used AI, and it made it different, okay? And all kinds of things happen, stories, narratives. But what we learned is there is a value in what they know and the behavior and why they do the routes they do. But AI says to do it this way to get the most optimization. So we posed through that problem at our vendor. And you know what they said? We're going to bring behavior of what the drivers are doing and how much time they're spending and how they're doing the routes. And we're going to measure that against the optimized AI-based optimization. And this is an early rendition of it. It's kind of a little bit of eye candy, but it's kind of fun too. So it's another model you can play with. What you see we have bright lights. What do you think that big red thing is in the middle, where it's tracking aggregate driver time and behavior? It's our headquarters. That's where they got to go every day. So that's why that pillar is just jumping off. But we're not going to spend too much time on this, but there is obviously data behind these symbols that eventually they're going to create an AI model that's using data analytics that we're going to get back to the users to use for planning and optimization. So there's that one. This is what the future looks like. That's a long list, but I'm hoping with the team in our relationship with WIT to start tackling these kind of things. And they're not your usual KPIs. So I've got work to do with my executive team too to make them think like this and not the standard KPIs that they might be producing or going up the chain to the board. These, to me, these are human impact. These are effectivity of the business, and this is where we're headed. So with that, with a couple minutes left over, any questions? That was a lot. I'm sorry. Go ahead.
The last image we saw on the map. So you have data, and AI is looking at stops. The AI is working out the optimal routes for drivers.
What AI is going to do, and they don't have it all yet, but it's going to say, this is what the system is predicting is the most efficient. The driver's behavior, because what they're doing is we're back to running the routes that they like to run. And it's going to analyze the effectivity of that and what's going on. Let's say it finds out that at this stop, it's unusually high. Like, what's going on there? Are they shopping it with a shopping cart? Like, what's going on? It's going to start to look at all the data behind what they're doing.
And the magnitude, just remind me the magnitude.
The magnitude in this simplistic model, it was just looking at time. So where are they slacking time at each place? The more they're spending there, because what we want them to do with that fresh food, get it off the truck, get going, but they're saying, but I got to talk to my guy. Okay, maybe there's value in that on the tribal side, but our master data in the logistics system doesn't know that. They don't know the value of that relationship. So it's going to start to look at this and try to identify where the outliers are, where things are happening. This is a great question. Anybody else?
Are you doing anything at the moment with graph analytics to analyze the routes or common places to pick up, common places to drop off?
So on the commercial driver side, there's more of a defined routes, like we have contractual obligations. But on the Harvest Heroes, who are the volunteer drivers, that would be a great place that we're just bringing them into automation. But that's a great idea. And I was hoping to get some ideas back. So even if they don't come out today, if you have some ideas on this and want to join in this journey, I'm all ears. Go ahead.
I got another question.
Sure.
More bad news. I've been doing demand forecasting for food banks as a volunteer.
Ah.
Using it to write grant proposals. Oh, the demand in your area, I don't know if there's been
I think I don't know if it's going to be on this slide. I'm looking. I would say we're not there, but that is an interest area. I think what we're doing right now is to use the data like you are more traditionally to get the funds, but we have a project right now. We got a $100,000 grant to do a very specific thing and connect with United Way. And this is specifically geared at optimizing and getting to more seniors and more. So we are bound to show that there's going to be growth based on creating this new technology. And we're going to have the data to prove that. So I don't know if that's a great answer to your question, but again, we're recording this, so we're going to be taking your ideas back with us as well. Go ahead.
Earlier slide, you had a KPI on waste. Have you ever overlaid where the source of waste is over the gaps to see where maybe not a supply demand issue, but it's more about timing and capacity?
Absolutely. So one of the things, in fact, I was in another conference downtown, CIO, and my board member was there, and I says, you know what we have to do? We have to start looking at our programs, because I intuitively think that there's one particular program we do where we're just not moving the food fast enough. But I don't have the data to prove that yet. But we have the data. So it's an effort of identifying all the programs, whether it be mobile pantry, getting it out to soup kitchens, bringing it back and gleaning over it. We call it grocery rescue gleaning. Like looking at those from a program point of view. And I think that's an analog in business too. You have different customers and different programs, whether it's manufacturing, automotive, whatever. Definitely that's on the list to do. Anybody else? How are we making money? So the food's all free. So the 50 million pounds of food. So put a street value on that. A lot of us, I do a lot of shopping. That's a lot of food at, let's say, $5 a pound on average or more. That's all given to us for free. So where we raise money is to run the trucks, to run the people involved in doing it, and we are dependent on the $35,000 volunteers. So a pitch. If anybody would like to come help us, you can do it individually. You can go to the website and sign up, or bring your corporations. A lot of the big corporations and small and medium are coming and bringing teams of 25. We really depend on that. So the real answer is we make no money. We go to a zero net profit game. We have to spend within our means. We have to operate within our means, unless we raise more money for a program.
You mentioned in your talk something about DTE. I actually work at DTE. I work in analytics for food insecurity as a volunteer. My paying job is for DTE.
All right.
What do you need?
So I'm a big one on synergy. When something like this happens, I don't just, it's happenstance. I would love to pursue, as part of our modeling, getting a hold of the predictive grid analytics that tell us,
Which I write.
Thank you.
That's my job.
Thank you. This is my dream. I didn't know my dream was going to be fulfilled today. Thank you. It's laying that on that ESRI model, that geographic model, so that we can know what we need to be looking out for this summer. Because I could tell you horror stories where it hit for like 10 days and you had a walled community that was compromised. We couldn't even get in to get the food there, and they had no provisions inside because they were protecting themselves against crime, but they created like a walled community, underserved. In knowing that that existed and they were on a bad grid would have been great, rather than in the moment having to deal with that. Anybody else? Thank you, everybody. I think we're out of time. Hope you got something. If you want to give me something back, contact me.